just looking at roots of unity with complex numbers. So we're looking at anything that is in the form of Zn equals 1. So if we start with Z3 equals 1, okay, then basically this equation will have exactly 3 real roots. It'll have one root, like if you cube root 1, that's an obvious root, that's a real root, and it'll also have 2 complex roots. Now firstly, we know it has 2 complex roots because when you go x cubed minus 1, the coefficients of that polynomial are all real. So if it has one real root, and then it has 2 other roots, the 2 other roots would either be complex conjugates or there'll be 2 real roots. Now this particular equation will have 2 complex roots. Now the complex roots that it will have is if you start here and you have that starts at 1, because we know one root's 1, and then the roots will be equally spaced. 2 pi is all the way around, and we know that there's 3. So if you divide by 3, they'd be equally spaced by 2 pi and 3, which is 120 degrees. So 2 pi and 3 is there, and then another root is there, so that's minus 2 pi on 3. So basically, your roots are cis 2 pi on 3, and then if you add another 2 pi on 3, you could write the other root, so we'll call that Z2, and this one Z3. That could be written in 2 ways. It could be cis 4 pi on 3, that's when you're coming around in a clockwise direction, but that is also the same as cis minus pi on 3. So basically, these roots will be in the form of z equals cis 2k pi on 3, where if k equals 0, can you see z1 is equal to cis 0, which is 1. If k equals 1, then z2 would be cis 2 times 1 times pi on 3, which is 2 pi on 3. And z3 would be cis if k equals 2, 2 times 2 pi on 3, or which is equal to cis 4 pi on 3. But if you put k equals minus 1, then you're going to get cis minus 2 pi on 3, which is the same thing. Because 4 pi on 3 is round to there, which is actually equal to 240, and minus 120 is round to there, so it actually represents the same root. Now, you could actually, through these roots, you could actually draw a circle. That's not a really good circle there, but its radius will be 1. So a circle of radius 1. Okay, and all of these roots here, I put them into mod, they're like in mod arg form there. All right, okay, with that one there. You notice that these 2 roots, they are complex conjugates. That's the other thing. And the other thing to be aware of is that when we can write these roots, like if we've got z cubed minus 1 equals 0, we know that the roots are z1 is 1, z2 is cis 2 pi on 3, and z3 is cis minus 2 pi on 3, or cis 4 pi on 3. Now, the roots are all of the form of cis 2k pi on 3. Now, I just want to show you that from scratch. Like if I had z cubed equals 1, and I let z equals cis theta, then that means that can be written as cis theta to the 3. Actually, I'm going to make that an r, cis theta. And on the right-hand side, that 1, that's cis 0. So that means that r cubed is cis 3 theta, and that will be 1 cis 0. So r cubed will equal 1, because the moduluses will be equal. R is 1, and 3 theta will equal 0. But if I keep adding on 2 pi, so you go plus 2k pi, so theta is 2k pi on 3. Therefore, the roots are in the form of 1 cis 2k pi on 3, and the k can actually come out the front. So that's cis 2 pi on 3 to the power of k. And that there is, that's the form of all of the roots. So very often then, you're then asked to do stuff with what you notice is omega. And what you do is you let omega equal cis 2 pi on 3. It's the complex number with the smallest positive argument. And then, so the roots are 1, then you've got one root with omega, and the other one, often you're asked to show that the third one is omega squared. Sometimes it's omega to the omega with a bar, or omega to the minus 1, which are all of these are actually the same thing. I'm just going to show you how. So they're actually all the same thing. So let's just look at, so z equals cis 2k pi on 3. Then that means that that's cis 2 pi on 3 to the k. So that means any root could be written in this form. So if we let omega, if omega was equal to, let's get this one. If omega was equal to cis 2 pi on 3, then basically that means that any root zk can be written as omega to the k. So the roots are in the form of 1, omega to the that will be omega to the 0, which is 1, omega to the 1, and omega to the 2. That's when k is 0, k is 1, and k is 2. So it's 1 omega and omega squared. Now, further on that, you're often then asked also to do stuff with this. So you can say, if you look at the sum of the roots, 1 plus omega squared, and you've got this equation here, then the sum of the roots would be equal to, now you notice that that's like bx squared plus cx minus 1 equals 0. And what's actually happened here is these must be, the c and the b must be 0, because that's why they're not there. So it's going to be minus b, which is 0, on this 0 here, on the 1 which is in front of the z cubed. So 1 plus omega squared equals 0. Now, so far, what we've done then, we have shown that the roots can be in that form there. So if you've got z cubed, you've got z cubed equals 1, then the roots are basically in the form of cis 2k pi on 3. So z1 is cis 0, which is 1. z2 is cis 2 pi on 3. And z3 is cis 4 pi on 3 if k equals 2. Or sometimes it's even written as cis minus 2 pi on 3. That's when k equals minus 1. And that's when k equals 2. And this is when k equals 1 and when k equals 0. So we have our roots. We also know that each of those roots then match up with, this one here would match up with 1. That one there is omega, and this one here matches up with omega squared. I just haven't actually shown this is omega bar or omega to the minus 1. Because if you look at that, that's cis 2 pi on 3, and you just make it to the minus 1. And that would be w to the minus 1. But I just want to show you also, so that's the same as cos minus 2 pi on 3 plus I sine minus 2 pi on 3. That will equal cos 2 pi on 3 minus I sine 2 pi on 3, which is actually equal to omega bar, or the complex conjugate. Okay, so we know they're the basic roots. We also know that 1 plus omega squared equals 0. And this helps us, if I want to simplify 1 plus omega, I can replace it with minus omega squared. 1 plus omega squared is equal to minus omega. And omega squared plus omega is equal to minus 1. So you can do different rearrangements of this. You can also realise because omega is a root, then when you substitute that, say, into z cubed equals 1, then omega to the 3 equals 1. So when you're asked to simplify stuff, like if you have omega to the 4, that's omega to the 3 times omega. Omega to the 3 is 1, which is omega. So the reason you can substitute omega in and get omega cubed equals 1 is because omega is actually a root. If you have omega to the 5, you can write it as omega cubed times omega squared. That's 1 times omega squared, which is omega squared. Okay, so you can actually simplify a whole lot of different things. Okay, so here's some actual examples where we're just going to simplify stuff. So we're going to simplify 1 plus omega minus omega squared. Now, we know that because omega is a cube root of unity, we know that 1 plus omega squared equals that. So that'll be 1 plus omega equals minus omega squared. Okay, just another way on that, I actually didn't show you this part. I probably should have just run through that as well. If z cubed equals 1, another way of showing that 1 plus omega squared equals 0 is to actually just factorise. So you factorise like this, and then you get z minus 1, z squared plus z plus 1 equals 0. And you let z equal omega, because omega is a root of this equation, so therefore it should satisfy it. So when you sub it in, you're going to get 0. Now omega minus 1, well, omega cannot equal 1, because omega is a complex root. So therefore omega squared plus omega plus 1 equals 0. And that makes it quite a simple way rather than going through and solving it. The other way is to solve it for all the roots first. And, you got the fact that the roots are in the form of 2k pi over 3, therefore in the form of cis 2 pi on 3 to the k. But if cis 2 pi on 3 equals omega, then they're all in the form of that. Then you put in k is 0, k is 1, k is 2, and you get the roots are omega to the 0, omega, and omega 2. So when you add those roots up, 1 plus omega squared, minus b on a. So the minus b will be 0 because it comes from the equation z cubed minus 1 equals 0, and there's no b there. So that's how you could get that equal that as well. All right, so let's go ahead and simplify this. So that means that in this particular question here, that means that's minus omega squared to the 7, which is minus 2 omega squared to the 7. So it's 2 to the power of 7 and omega to the 14. Now 2 to the power of 7, I think, is 128. Yeah, it'll be 128. Okay, so looking at this one here, we're going to have to rearrange the 1 plus omega squared and make that equal minus omega. So then you have minus omega. This is the left-hand side, which is minus 2 omega, and it is all to the power of 4. Now, I think that question actually should have a 4 on there, otherwise it won't work. Minus 2 to the power of 4 is 16, and then it's 16 omega to the 4. Okay, so looking at this one here, first thing I do is left-hand side, you probably need to get a common denominator. So it's 1 plus omega squared, which is 1 plus omega squared minus 1 plus omega. So it's 1 plus omega squared minus 1 minus omega, all over. Now, on the bottom, we could go ahead and kind of see if we can change it, or we can expand it all out. Changing it, 1 plus omega is minus omega squared, and 1 plus omega squared is minus omega. So it does give a single denominator. See, that's minus omega squared times minus omega. And then, see, the bottom now becomes omega cubed, because the minus times the minus disappeared. And on the top, they cancel out. And you end up with omega squared minus omega. There is a common factor of omega there, but I know omega cubed is 1, so I'm going to make that omega squared minus omega. Now, this here is all in terms of w, so why don't we make 1 plus w equal minus omega squared. So omega squared is actually going to be minus 1 minus W. That's a better way of writing it. So the W squared is minus 1 minus omega, and then minus this omega here. So you can see what I actually did is I looked at the price where I was heading, and that was that. So it's minus 1 plus 2 omega. So if you look at that, we're now very close. It's minus 1 minus 2 omega. If you take the minus 1 out, it would be 1 plus 2 omega.